more than welcome to ask questions at any time. Don't hesitate to interrupt, because chances are if you've got the question, somebody else has the question too. So when we're looking at dividing radicals, just kind of like when we were, so just a reminder with multiplying radicals, I'm going to give you the like true Coles notes of this. So if I had a radical of 4 root 2 and I'm timesing it to, let's go 3 root 5. So the one thing you have to remember when you're multiplying radicals, you have the same root that you're working with. Okay, so if they're square roots, you're working with square roots. You take your coefficient out front, so the 4 and the 3, they're going to get multiplied together. Okay, and then whatever's in your radical underneath, they're going to get multiplied together. So you're going to be left with 12 square root 10. Now, when you end up doing that, what you want to take note with this is make sure, hey, can you simplify the root 10? Is there a perfect square that goes into 10? And in this case, we don't have a perfect square that will divide evenly. So if I think perfect squares, I'm thinking 2 squared. Well, that would be 4. 4 doesn't divide into 10 evenly. You'd end up with a decimal out of it. So in this instance, you would be simplified. Okay, that is like truly the Coles Notes version of that. But that same idea of when we are multiplying our coefficients together and then multiplying our radicals together kind of spins into what we're going to do with dividing. Okay, so if you haven't got to this part on the multiplying piece, please check out the video lesson on Google Classroom. Okay, there's one that's pre-done in there that you'll be able to look at to kind of cover your basis on that. Okay, so when dividing, same thing. We're going to divide the coefficients. So the numbers out front we'll end up dividing when we can. And then you can divide the Radicands underneath. Again, you have to make sure the only time you can divide radicals is if you have the same index. So they both have to be square roots, or they both have to be cube roots, right? Like they have to have the same index to them. So when I look at this, and in my notes, I don't know if you, hopefully it shows up better on yours. You've got, this is 4 cube root of 6. Okay, so the little index number here is a 3. And you're dividing that by 2 cube root of 3. So because you're only working with one radical on the top, and you've got one single radical in the denominator, then we can go through this process of, hey, I'm going to divide out my coefficients. So in this case, 4 divided by 2 gives me 2. And then if I'm looking at what's underneath my radicals, I've got 6 divided by 3, which is going to give me a 2. So my final answer in this case would be 2 cube root 2. Okay, so I've taken my coefficients up front, divided them, and then I've taken my Radicands and I've divided them out, and that's given me 2. Questions on that?
No.
Nope. Okay, moving on. Let's look at the next one. So same thing. I got a single radical on the top and I've got a single radical on the bottom. So I'm first off going to look, can I reduce my coefficients in front? The same thing. I've got 6 divided by 3. I know that's going to work out to a 2. And then I think about my roots. I've got root 12 divided by 6. That's going to give me a root 2. So again, done. Okay, so try the next one. Same thing. So we're going to take the negative 24 divided by the 8. Well, that's going to give me, don't forget your sign, you've got a negative 3. And this is the cube root. So if I look at 14 divided by 2, that's given me 7 as a resulting answer there. So those aren't so bad, are they? Okay, have a look at this next one. We don't have any coefficients up front, but at the same time, you still can, it's like saying a 1 divided by 1. So because it's just a 1, we don't need to actually write it. But now we can go with what's inside our Radicands. I've got an 18 divided by 3. Well, that is going to give me a 6. And x cubed divided by an x. Don't forget, when you are dividing your exponents or your bases, your exponents you subtract, right? So this is really saying x to the power of 3 divided by x to the power of 1. Well, you're really taking x cubed, subtract 1. So you really have x squared as a resulting answer there. Now, again, you're always looking, can I simplify what I have underneath my root? So if I look at the 6, so I look at the numbers first, there's no perfect square that will go into 6, so it's going to stay put. So I can't simplify that anymore. You guys, even online, you're just making faces at each other. Okay, you've got the x squared. What's the square root of x squared? That ends up being, I can actually take out an x, and I'm left with a root 6 underneath. So really this piece, the square root of x squared, becomes an x. That's what's coming out, and I'm still left with the root 6 underneath. So this would be considered my simplified form. Now, all of these that we've done are pretty straightforward. They've divided, our coefficients have divided out nicely, our radicands have divided out nicely, and I'm left with some pretty nice, neat, and tidy answers when I'm done. Now, not every question is going to divide out wonderfully like this. We check it first and see, because if we can eliminate, because the idea here, well, and this is going to be a long time ago. Remember the very first day when we started radicals, I said, hey, we never want to leave a root in our denominator. And ideally, when we divide these out, every single one of these, we were able to get rid of that radical in the denominator. What happens if this happened to be a 3 in here instead? If this was a 3, I can't take 14 and divide it by a 3. That's not going to divide out evenly. So now I'm going to have a problem where that I can't get rid of that value in the bottom. So what we end up doing is something what we call rationalizing the denominator. So that is, in a sense, a way of getting rid of that root out of the bottom. So in order for us to do that, we're going to eliminate it without changing our answer, but we're going to just manipulate the whole fraction so that we can get rid of that root. So in this instance is a perfect example of, I've got my coefficients, okay? They're not dividing out evenly, so I'm not touching them. I have a root down in the denominator, but I don't have anything up top that I can divide it by. So I am in this situation now that there's nothing that will divide out, but I still have this root in the bottom. So in order for me to get rid of it, what I could do, it's like if I had 3/4 and I said, I want to multiply that by something, but still have an equivalent of 3/4. So I could multiply this by a 2/2, right? I would end up with 6/8, which is still an equivalent fraction to 3/4. So I didn't change what that fraction is. So all I did was multiplied it by a form of 1, right? Because 2 divided by 2 is just the equivalent of 1. Well, I'm going to use this same thinking with what I'm going to rationalize this denominator. So instead of, I can pick any number I want to create a 1 out of it, well, here's what I'm going to do, is I'm going to take and multiply the bottom by √3 and the top by √3. Because by multiplying, so here I've got √3 over √3, that equals 1. But look at what happens to my fraction then when I do that. So in the top, I'm going to have 5 times that √3, which is going to give me 5√3. And on the bottom, I end up getting 2 times, well, √3 times √3 is √9. So I still have a root there, but wait a minute. The square root of 9 is what?
3.
3. So if I take the square root of 9, it's 3. Guess what? I've gotten rid of my root in the bottom, which is my ultimate goal in this. So now what I've got going on is I have the 5 root 3 on the top, and I've got 2 times 3, which is 6 on the bottom. And now what you just literally did was rationalize the denominator by multiplying by that root that was in the denominator already to both the top and the bottom, which is essentially like multiplying by 1. So it did nothing to the quantity of my fraction, but it allowed me to get rid of that root in the bottom. How's that feel?
Fantastic.
Good answer. Good answer. Okay, so let's try another one. This one, if I look at 2 root 5 over 3 root, this is a cube root of 6. Oh, that's not a fun one to do. Hold on a second. See if we can change this up a little. Okay, we'll do it because we're going to have to do it anyway. So, okay, so this time when we did it over here, we did the square root. We ended up multiplying it once to itself because multiplying it once to itself gave us the square root of 9. And when we took the square root of that, we got rid of our root. Here this time, you've got a cube root. So instead of only multiplying it by 1 over here, we're going to end up multiplying this by 2 of them. Because what happens then is I've got 3 6s here that get multiplied together, right? So this is the cube root of 6, the cube root of 6. And then I have to do the same on the top. So now what I got going on the bottom, I'm going to have the 3, and then I've got the cube root of whatever 6 cubed is. So 6 times 6 times 6. So 216. That's the bottom. The top now, here's the kicker. So from Tuesday's assignment, when we said we were multiplying, we have to multiply same radicans together. Well, I've got a square root. So really I have 2 root 5, but then I've got this cube root of 6 times this cube root of 6. Well, that's really the same. So I'm timesing by the cube root of 6 times 6 gives me 36. I cannot combine this cube root of 36 with this square root of 5 because they have different indexes. So this just stays as I'm multiplying these together, right? All of these, they're just showing it as being multiplied together. Can't simplify that anymore. So the top stays as 2 root 5 cube root 36. On the bottom, again, I've got 3 and the cube root of 216. Surprise, surprise, is the 6 that we had. So you're going to find here too, as you go through this, you're going to see, I don't necessarily have to see the cube root of 216. You know that when you take the cube root of 6 times the cube root of 6 times the cube root of 6, you're going to get a resulting answer of 6 because you basically have got that group of 3 6s that satisfy that. So that means that bottom then, instead of it being 3 times 6, I can rewrite this as 2 root 5 times cube root of 36 over 18. Which, we have one more thing we can do with this. So now take a look at your coefficients that you got going on. So I look at the coefficient of 18 and I look at the coefficient of 2. So this is like saying 2 over 18. Can you reduce that?
Yes.
Yeah. So I basically have square root of 5 times the cube root of 36 on the top. And I can take a 2 out of the top and I divide the bottom by 2, which is going to leave me with a 9 in the denominator. So that would be my most simplified answer to that question. Questions on that so far?
No, it's pretty straightforward.
Frito, you got anything?
What's that, Zach?
I asked Frito if he's got anything. No,
Stay quiet.
I'm just fantastic. No, I'm good.
That's good. You guys paying attention more because you're not actually in the same room?
Yeah.
I guess so. Yeah.
Sure. Don't lie to me. Okay. So let's look at the
Something
next
like
one.
that.
So the next type that we've got is, so we looked at rationalizing where we had just a denominator with one radical in the bottom. Okay, or one term, I guess, in the bottom. Now let's look at the radical, this expression where, look at, we've got a 4 minus a root 6 in the bottom. Well, in order for us, we still got to get rid of that root 6, but we're subtracting in here. So we've got, essentially, it's a binomial. These aren't being multiplied together. So this is going to create a little bit different situation. And what we need to do is what we call, we've got to take the conjugate of the denominator. So in order, what basically finding the conjugate of the denominator is if I've got 4 minus root 6, the conjugate of 4 minus root 6 is the opposite in terms of I am subtracting here, but the conjugate of it would be 4 plus root 6. So what we are going to end up doing, again, that same scenario of rationalizing that denominator like we did in the other ones, we're going to multiply by the conjugate top and bottom. So we're still multiplying it by a form of 1. It's just that is a binomial divided by a binomial. It still represents 1. It's going to get multiplied to both the numerator and the denominator. So what does that look like? Well, that means I've got this 5 root 3, okay, what's in the numerator, is going to get multiplied to both terms in that binomial. So this is really saying 5 root 3 times that 4. So it's really the 4 times that 5, which is 20 root 3. And then I'm going to take that 5 root 3 and I'm going to times it to the root 6. So this time I've got a 5 times, there's no coefficient out front here, it's just a 1. So it would be 5 times 1, which is going to give me 5. And root 3 times that root 6 is giving me root 18. That's the top. Now I got to come to the bottom and I've got to multiply all of this out. So this is kind of, you're getting a little bit more of that crash course from Tuesday when we were multiplying radicals together. So same idea, you've got this, you're dealing with two binomials, you're going to distribute through. So you're going to multiply that 4 to that 4, which is going to give you 16. You're going to take that 4 and you're going to multiply it to the root 6. And you're going to get plus 4 root 6. Then I'm going to take the negative root 6 and I'm going to times it to the 4, which again, that 4 is like a coefficient out front, so it's going to be a minus 4 root 6. Then I'm going to take that negative root 6 times that positive root 6, which is going to give me a negative root 36. So you're probably looking at that going, wait a minute, there's still roots in the bottom. But watch this. I've got a root 6 and a minus root 6. Well, that zeroes out. So that no longer exists anymore. So now what I've got going on is I've got 16 and I've got subtract the square root of 36. What's the square root of 36? That works out to 6, right? Yep. So that's the bottom. So I'm actually was able to clean up that bottom. And this is going to happen every single time, you guys. If you multiply by the conjugate, look at what happens. I've got my first two terms that I multiplied together. That's where my 16 came from. And if I multiply the second two terms together, and I'm taking it as a subtraction, I get that last term. I really don't have to multiply all the other, the middle terms are going to cancel out, always. The middle terms will always cancel out when you're multiplying by the conjugate. Okay, so you'll be able to shorten that up too moving forward. So the top, we still have this as 20 root 3. Now, have a look at 5 square root 18. So now we got to start to think about, hey, can I take that square root of 18 and can I simplify that? Is there a perfect square that will divide into 18 evenly?
Yeah.
Yeah, what is it?
9.
You betcha. So really, I'm looking at this as really the 18 is the same as saying 9 times 2, right? What's the square root of 9?
3.
3. So it's really the 3. I'm really going to have the 5 times the 3 that's going to come out front. And you're still going to be left with the 2, root 2 still left there. So I can take and simplify that. So let's clean this up again. So I'm going to have 20 root 3. I've got the 5 times the 3, which is 15, root 2. And on the bottom, I've got 16 minus 6, which is going to leave me with 10. So basically, what I've got left now is I look at my radicals, which we've simplified them as much as we can. So that's a good thing. So the only last thing that we want to account for is, hey, look at the coefficients. So I've got the 20 over 10 and the 15 over 10. I've got those 3 coefficients that I got going on. Can I find a common, a factor that is divisible into all 3 of those? Because if there is a number that is divisible into 20, 15, and 10, I can reduce this fraction down. And I am hoping you're saying 5, right? So essentially, what I can do is divide the 20 by 5, which gives me a 4 root 3. I can divide the 15 by 5, which is going to give me 3 root 2. And I divide the 10 by 5, which gives me a 2. And that is where I can leave my answer. How does that feel?
It's a really long process, but it's pretty straightforward.
It is. This is the piece that you guys are going to want. That's why I said I recorded this lesson, because at least you guys will be able to go back over and look at it again. But we'll do a couple more just to kind of let it do some processing for you, okay?
You feeling good, Frito? Oh yeah, we are. We're good.
I think his screen froze on my end. Okay. So let's go back to some.
What did you say?
We're hoping you feel still good about yourself. All right, so first things first, what I want you to account for in here, you get a question. I want you to always see if you can divide things out first to eliminate that radical. It's not wrong if you decide to just go straight to rationalizing top and bottom. What's going to happen is you're going to get some bigger numbers to contend with and simplify. So if we can do any reducing ahead of time, it just makes your life easier after the fact, okay? So I look at this and go, no coefficients out front to divide out, but I do have a 24 and a 3. And I know when I have that 24 divided by 3, I know I'm going to get an 8, okay? And then my last thing is I've got an x squared divided by an x. And I know that is going to give me an x. So now I've got square root of 8x. Now your question you have to ask yourself is, am I done? Can I reduce that 8? Can I simplify it? And I
think so, can't you?
Yeah, I hope you say that you've got a 4. This is the equivalent of saying 4 times 2, right? That 8. So 4 is a perfect square that can divide into 8. So in that case, the square root of 4 is 2. And what am I left with underneath? I am left with a 2x underneath. So this, I'm taking the square root of the 4, and that's what's coming out here. And the root 2 is still staying underneath. And the x, I don't have x squared happening here. So I can't even pull a group of x's out. So that x just stays underneath. So this is what I should have for an answer. Okay, let's look at the next one. The next one is 4 square root 5n divided by 3 square root 2. So just by a quick look at it, I look at my 4 and my 3, they don't divide out evenly. I look at the 5n and the 2, they don't divide out evenly. So in this instance then, this is a prime example that we want to rationalize the denominator, meaning I'm going to multiply the numerator and the denominator by whatever that radical is in the bottom. So that root 2, it's going to get multiplied to both top and bottom. So that means I've got a 4 times a 1, which is going to leave me with a 4. And I've got root 5n times 2. That's going to give me 10n. And on the bottom, I really have 3 times, well, again, think about this. Root 2 times root 2, that's going to give me a root 4. And the square root of 4, that gives me a 2. So now what I can start to do is I can start to simplify again, right? So I could either multiply the 3 and the 2 together, which would give me a 6 on the bottom. And then I'd have to look at, hey, I've got coefficients of 4 and 6 that I would have to reduce. Or I can look at this and go, hey, 4 divided by 2 gives me 2. So 2 goes into itself once, 2 goes into 4 2 times. So I really have 2 root 10n over 3. So you've got a couple different ways to get that reduced. If you're more comfortable with multiplying the 3 and the 2 together first and then reducing after, great. It will work out the same way no matter what. Okay, how was that?
Sorry.
All right. That's okay. Zach, you look thoroughly bored.
I'm just tired. I worked this morning.
Oh, you put in a shift already. Good for you. Okay, so now you've got 11 divided by root 5 plus 7. So this is that example where you've got a radical plus another number. So you've got that binomial happening under here. So what we want to do is we're going to multiply by the conjugate. So that means I've got root 5 plus 7 in my denominator. So I'm going to multiply by root 5 minus 7. And I'm going to do that top and bottom. So on the top, that means I've got the 11 is going to get multiplied to the root 5, and it's going to get multiplied to the 7. So the 11 acts as a coefficient. It doesn't get multiplied to the root 5, like to the 5 underneath the root. It just stays put outside the radical. So I'm going to have 11 root 5. And then I'm going to have the 11 times the negative 7, which is going to give me negative 77. So that's the top. Now on the bottom, same thing. So remember in that last example, we're back on the first page, let's multiply the first 2 terms together, which root 5 times root 5, that's going to give me root 25, which is really the equivalent to saying 5. Okay, so I can simplify that kind of in my brain as I'm working through this. I don't need to do the middle terms, but I do need to do the 7 times the 7. And that 7 times that negative 7 is going to give me a negative 49. So now I'm going to take the 11 root 5 minus the 77, and 5 minus 49 is going to give me negative 44. One more step to focus on then with that is I want you to look at, again, look at your coefficients. So you've got 11, you've got negative 44, you've got negative 77, okay? I'm hoping you're seeing that you can divide each one of those numbers by 11. So if I take 11 divided by 11, that's just going to give me 1. I don't need to write the 1, but I'll just put the root 5. And then negative 77 divided by 11 is going to give me a minus 7. And negative 44 divided by 11 is going to give me a negative 4. And that is my final answer.
Oh.
Somebody's having fun.
No doubt.
That's my dad.
Oh. Well, he's happy. Okay, I think what we're going to do, the next one here is pretty straightforward to what I've shown you. And this one is like what we just finished doing, so I'm not going to do that one. But let's do C. Let's do this 2 plus root 2 over 3 root 5 minus 4. Oh, I ran off your page. There we go. Boy, is it ever windy out. Okay. So, same idea. You've got a binomial happening in your denominator. So I want you to multiply. We're going to multiply by the conjugate. So the 3 root 5 plus the 4. And I'm going to do that top and bottom. So this one's a little bit more, in the last question that we only had one single number up in our denominator, and we just distributed that to both terms in that binomial. Well, here in this scenario now, you've basically got a binomial times a binomial. So we are going to have to multiply this out. Like we're going to have to take that 2. It's going to get multiplied to both terms in that second binomial. And then we also have the 2 that's going to have to get multiplied to both terms. So let's start to multiply this out to see what we've got. So in this instance, I'm going to take the 2. It's going to get multiplied to the 3 root 5. But it's the 2 and that 3 that are getting multiplied together. So that's going to give me the 6. And I just have a root 5 happening. Then I'm going to take that 2 and it's going to get multiplied to the 4. That's going to give me that 8. Then I'm going to take that root 2 and it's going to get multiplied to the 3 root 5. So the 3, there's a 1 out here. So 1 times the 3, which is going to give me 3. Then the root 2 times the root 5, that's what gives me root 10. And then my last, I've got root 2 times that 4. Again, this 4 is not in a radical, so the 4 is getting multiplied to that imaginary 1 out front. So it's going to be a 4 root 2. So that's all on the top. These ones get a little long because you've got lots of terms that are getting multiplied together there. So on the bottom, same thing as what we did up in the question up above. We're going to take the first term and multiply it to the first term over here. So that really, 3 times 3, that gives me 9. And root 5 times root 5 gives me root 25, which really is 5. So I'll have 9 times 5 there. I'm doing this and this. And then I've got minus my last 2 terms that I got to multiply together. So 4 times the 4, which is going to give me 16. So at this point then, you're at the point of just cleaning up the numerator, gathering what we can together, and then cleaning up the denominator. So first off, you do a quick glance across your terms in your numerator. I've got a 6 root 5. Can't reduce the radical of root 5. So nothing's happening there. I'm going to rewrite it. I've got an 8. Nothing special there. Going to rewrite it. The 3 root 10, same thing. There's no perfect square that will go into root 10. So it stays as is. And I've got the 4 root 2. It stays put. So nothing in the top can add. There's no like radicals that I can add together. There's nothing that I could reduce or simplify. So it stays put like that. And on the bottom, I have, this is 45 This is 45 minus the 16. So on the bottom, I've got, what does that work out to, 29? So now my last step that I would be looking for in this is to look to see if my coefficients, I've got a 6, an 8, a 3, a 4, and a 29. So if there by chance would be a number that would divide into all of these coefficients evenly, then I would end up dividing it out of every single coefficient. But 29 is a prime number, and I'm dealing with 3, which is another prime number. There's no numbers that will divide into all of them. So in this case, this is where we stay put.
Deal.
Questions? Concerns?
I'm just concerned about Frito, not gonna lie.
No.
Yeah.
I'm
Don't
good.
give me a hard time.
I'm joking, buddy. It's because I miss you.
See, aw, that's nice. Do you guys not
Out there.
FaceTime?
We did before this class.
Oh, okay. I just got the impression that you guys hadn't
So
seen
what
each
did you
other for
say?
a long time.
Well, I said how we haven't seen each other in a minute, Frito. I don't
Okay,
think you can hear
so
me.